So, hello everyone, welcome to our Ask Geology, a whole new way to understand our Mother Earth. So, in this today's 7-minute numerical, we'll be discussing about one question related to your structural geology. This is not actually a numerical where we will not be using some numbers, but this is basically a conceptual question related to your Mohr circle. Okay, basically all of you know what this Mohr circle is used for, and this Mohr circle that basically defines, or this is the pictorial representation of your state of stress of a particular body at a particular time. Okay, and all of you know the stress ellipsoid, strain ellipsoid. For that we use also Mohr circle, and it has a very vast implications, and it is also important from the exam point of view. Okay, so this is the question number 14 asked in gate 2018. So the maximum and minimum principal stresses, okay, this is principal stresses are denoted by sigma 1 and sigma 3. All of you know, when we are considering a particular body, three-dimensional body, okay, that is maintained at a stress condition, okay, it is some stress is acting on its body, on this body. Then to characterize the state of stress, we just consider the principal stresses. Okay, so if we just consider this state of stress, we just want to demonstrate or to just describe, then this comes in a matrix form. Okay, there are so many of parameters associated with these things, and by simplifying those things, we just come to the conclusion that that is the 3 cross of 3 matrix. And in this case, we just to find the three principal stresses, that is sigma 1, sigma 2 and sigma 3. And by convention, sigma 1 is considered to be the maximum one, and sigma 3 is the minimum one. Okay, this is the maximum principal stress sigma 1, and sigma 3 is considered to be the minimum principal stresses. Okay, this is our convention. We just remember those things in this manner. Okay, so the differential stress can have an absolute value that will be greater than sigma 1. All of you know this differential stress, how this differential stress is calculated. Okay, like sigma differential. Okay, that will be differential stress, that will be calculated by sigma 1 minus of sigma 3, that is the maximum minus of a minimum. And all of you know there are various types of stresses, that is the differential stress. One is your mean stress. For the mean stress calculation, we use sigma 1 plus of sigma 3 by 2. And there is one effective stress. Okay, there is one effective stress. After this solution, okay, I will be talking something about this effective stress. Okay, so in this case he is asking that at what condition, okay, at what condition, or at what state of stress of a body, okay, the differential stress will have a greater value than the sigma 1, or the maximum principal stress. Okay, for this let us just consider this one. And in this case, this is basically the Mohr circle. Okay, this is Mohr circle. For understanding, I'm just telling these things, huh? And this region is conventionally taken to be positive, and this to be negative. Okay, and this is considered to be your compressive region. This is your compressive region, and this is tensile region, always remember. And this is the origin, that is 0 0. Okay, this is 2D representation of your state of stress, that is Mohr circle. Okay, now you are considering, let us just consider the case 1. Now we will take sigma 1 and sigma 3 value. Okay, now it is considering sigma 1 and sigma 3 both are compressive. Both are compressive means they will have positive values. For this, let consider a case. This is sigma 1, let 5 MPa, this is MPa megapascal, that is the unit of your stress. And let this to be sigma 3, which is 2 MPa. This is the case. Now the first case is considering both are compressive. So if we just calculate the differential, this is 5 minus of 2 is equal to 3 MPa. Now 3 MPa or 3 megapascal is not greater than the sigma 1. So this condition is not applicable. Okay, so let us just go to the second case. Okay, let us just go to the second case where it is telling that the sigma 1 is compressive and sigma 3 is tensile. Now sigma 1 is compressive, so that will be positive. Okay, it will have a positive value. Let it to be 4 MPa. This is the second case. And it is negative, sigma 3 is tensile. Let it to be 2 MPa. Okay, 2 MPa. This is magnitude is 2 megapascal, but it is tensile. That's why we'll have to give a negative sign. So what will be the differential stress? Okay, that is a differential will be 4 minus of 2, that is 4 plus of 2 is equal to 6 MPa. Now this 6 MPa, or the differential stress magnitude, is more than the sigma 1, that is the maximum principal stress. So this condition is satisfying, or this is actually the answer. Okay, so let us see that if this C or D are applicable in this case or not. So for C, I'm just changing the color again. Okay, now for the C, sorry, for C, sigma 1 and sigma 3 are equal. If both are equal, then what will be the differential? Equal minus of equal, that will be 0. It will be present at this point. Or this sigma 1, that will be negative, or that will be less than the sigma 1 or the maximum principal stress, because it will have some numeric values. Okay, and the fourth case, sigma 1 and sigma 3 are both are tensile. If both are tensile, they will be present in negative side. So let us consider one case, this to be 3 MPa, this to be 5 MPa. Okay, so in this case, sigma 1 will be minus of 3 MPa, and sigma 3 will be minus of 5 MPa. Now if we just add sigma 1 minus of sigma 3 is equal to, this is your 2. Okay, minus of 3 plus of 5 is equal to 2 MPa. 2 MPa. Now you just calculate, or you just think, this is minus of 3 MPa, minus of minus plus 5 MPa, this is 2 MPa. Now this numeric value is coming in positive, 2 MPa. Now you just think that if both are tensile, how you will just uh, generate the differential stress to be positive in this compressive region? So it is not possible, first thing. And second thing, always remember that the amount or the stress, the magnitude of your stress, okay, the magnitude of your stress, that cannot be zero, or that cannot be negative. Okay, so this positive and negative sign, okay, the sign, this positive or this negative sign is nothing but related to our convention. These are the sign convention assigned to these things. Okay, and this 2, if this is minus of 2 megapascal, then this is also not greater than this 3 MPa sigma 1. So this D is also not correct. So in this case, this B is actually your answer. Okay, and this is sigma 1 minus of sigma 3. Okay, ठीक है, no problem, no, don't get confused. And another thing, this differential stress, if you just consider the differential stress, that it takes in account, or it considers the pore pressure, where this is called sigma star, that is the effective stress. This is basically the sigma minus of p is your pore pressure. For sigma 1 star, we'll be counting sigma 1 minus of p. If it is sigma 3 star, then sigma 3 minus of p. Okay, so this effective pressure, or the effective stress, that plays a great role in just defining the concept of your landslides. Okay, if we just consider in this case, okay, this is the Mohr Coulomb failure envelope. Okay, Mohr Coulomb failure envelope. Now in this case, if this body is present here and it is stable, okay, now it is containing some amount of pore pressure, then the shape of this circle, that will not change, or the state of your stress of this particular body, that will not change, but it will move towards this direction if pore pressure is associated with it. And if when it touches this curve, touches these tangents, then you know that when it touches this, then that is the condition of your failure. Okay, now this body will fail. And this is basically what actually happens when this pore pressure increases, landslide type of things they actually increase. Okay. In many a times you might have seen some news related to this Uttarakhand. Okay. In rainy season there are so many of landslide. Okay. In rainy season there are so many of landslide, because what actually happens, now this liquid or the water that comes into picture, and they reduces the overall stress condition of a particular mass or particular body, and that actually makes it to fail. Okay. That's why in rainy season so many of landslides are there. So in this case, this B is your answer, and I hope this much of description is better or sufficient to understand this type of questions. So if you are interested to join our group, then you can contact to these numbers. You can put a mail to this mail id, or there will be a link provided in the description box. By clicking on that, you will be getting access to all our social media platform. And always remember, this is our motto: save our mother earth. That means plant more trees, go green. And thank you very much. So if you have any kind of doubt, then you can directly put your queries in the description box or in the comment box. No problem, I will love to just solve your doubts. Thank you.